Hi guys, I am Sriram.r, studying in Sri Venkateshwara College of Engineering. Subject is Mathematics 2 and the topic is Vector Calculus. Vector calculus is a powerful mathematical tool that extends the concepts of a single variable calculus to multi-dimensional spaces. It provides a framework for analyzing and understanding the behavior of the vector fields, which are essential in the fields like physics, engineering, and the computer graphics. Vectors and the vectors operations, geometric representation, vector addition, scalar multiplication, vector subtraction. The geometric representation is the vector or the geometric quantities with the both magnitude and the direction represented as a directed line segments in the space. The vector addition is the vectors can be added by placing them to tail, resulting in a new vector that represents their combined effect. A scalar multiplication, multiplying a vector by a scalar number changes its magnitude while preserving its direction, making it a usable operation. The vector subtraction is the subtracting one vector from another is equivalent to adding the negative of the second vector to the first. Scalar and vector fields are: a scalar field is a function that assigns a single numerical value to each point in the space. In a contrast, a vector the fields assign a vector to each point, specifying the both magnitude and the direction. Examples of the scalar fields includes the temperature, pressure, electric potential. Example of the vector fields include the velocity, acceleration, electric or the gravitational fields. Gradient of the scalar field. Definition. The gradient of the scalar field is a vector field that points in the direction of the maximum rate of the change of the scalar field. Geometric interpretation. The gradient vector is a perpendicular to the level curves of the scalar field and points in a direction of increasing values. Applications. Gradients are used to find the direction of the steepest ascent and descent and to define the conservative vector fields. The gradient of the scalar field is a powerful mathematical tool concept that allows to quantify the rate of the change of the function by analyzing the gradient. We can determine the direction and the magnitude of the steepest increase or decrease in the function values, providing values insights for the various specific scientific and the engineering applications. Divergence of the vector field. Understanding the divergence mathematical definition. And the divergence is a scalar field that describes the density of the outward flux of the vector field and the intermissional volume around a given point. It measures the extent to which the local behavior of the field at the point resembles the source or a sink. Mathematical definition. The divergence of the vector field f is equals to f1, f2, ft3 is defined as the scalar field division of the f and the alpha f1 by the alpha x by alpha f2 by alpha y plus alpha f3 by alpha z. A curl of a vector field. A curl of a vector field is a measure of a rotational behavior of the field around a given point. It is a vector quantity that indicates the strength and the direction of the rotational motion of the field. Physically, the curl represents the circulation or the vorticity of the vector field. It is a fundamental concept in a vector calculus and has important applications in the fields like electromagnetism, fluid mechanics, and mechanics. Line integrals. Path dependent value depends on the path taken. Scalar fields. Integration along a curve. Vector fields. Work, flux, and the circulation. Line integrals are used to calculate the quantities that depend on the path taken through a field, such as a work, flux, and the circulation. They can be evaluated for the both scalar and vector fields by integrating along a specific curve or a path. The value of the line integral is a path dependent, meaning will change depending on the route between the start and the end points. Surface integrals: definition, application, calculation, parameterization. Definition: a surface integral is a generalization of the definite integral of two functions of two or three variables defined on a surface in a space. The applications: surface integrals are used to calculate the flux of the vector field through a surface, work done by the force field and the total charge on the charged surface. Calculations: to calculate a surface integral, we divide the surface into small elements and evaluate the function over each element and taken in the sum of the events. The surface is often parameterized using the vector valued function in two variables, allowing the surface to integral by written as a double integral. Green's theorem. Overview of the Green theorem is calculating the line integral and the relationship to the theorems. Overview of the Green theorem. The Green theorem relates the double integral of the vector field over a region to the line integral of the field around the boundary of the region. It is a powerful tool in the vector calculus with a wide-ranging applications. The calculating the line integrals. The line integrals is the Green theorem captures the net circulations of the vector field and around the boundary of the region that provides a way evaluate the integral without the directly integrating over the entire region. The relationships to the theorem. Green's theorem is closely related to the other fundamental and the theorems uh, fundamentals in the vector calculus such as divergence theorems and the Stokes theorems, which connects the surface integral and the volume integrals to the line integrals. And Stokes theorem, fundamental theorem, boundary curves applications. Stokes theorems establish the fundamental relationship between integrals and the surface integrals, unifying the different concepts in the vector calculus. Boundary curves. It states that the line integral of the vector field around the closed equal to the surface integral of the curve that field over any surface bounded by the curve. Application. Stokes theorem has many important applications in electromagnetization, dynamics, and other areas of the physics and engineering, and providing a power to the tools for analyzing the problem solving. Thank you guys.